I should do this. So it's going to be P. Now let's think about it. If you had no taste buds, what's your chance of guessing correctly? Think about how many colors there are in Skittles. There's 5 colors, right? So what's your chance of just straight up guessing, no tasting? 1 out of 5, which is 20%, right? You with me? So that would be the null hypothesis. 20% chance of just straight up guessing, but we're saying we think it's higher, right? How do I know that? Because our sample is higher. So the question is, are we just really good at this? Or is it true that you really can taste it? We're going to find out how often that really happens. So greater than 0.20 is our alternative. Okay? It's like saying this person's on trial and I have evidence of his guilt and I think it's strong enough to say he's guilty. Okay? So significance level, we're going to use the default of 0.05. Okay? So that's the first step. We call it the state step. You just state the hypothesis. That's the biggest piece of information you got to give us with the correct symbols and all that business. All right? Procedure. Right now we just have, as far as procedures, you've done confidence intervals, right? Now we're doing hypothesis tests. So it's going to be a 1 proportion z-test. Name of procedure is not a big deal for you right now, but that's okay. Conditions. What are the conditions we always have to check? Normal and random. So was our sample random? Yes, we were all there. It was very random. And then how do I check if it's normal? Central limit theorem is not going to work in this case because it's proportion. Central limit theorem only works for averages. So large counts test is where we have to go. All right? So we have to use a large counts test. So remember, that's just n times p hat. No, it's n times p, sorry. Greater than 5, and then n times 1 minus p, greater than 5, right? So 110 times 0.47, we already know that number was 52. Greater than 5, yeah. 110 times the complement, what, 0.53? Is that 58? All right, that is satisfied, so we know it's approximately normal. So the key thing on that is you just got to recognize its proportions. To check normality, I do large counts. Yeah? Remember that? All right. Formula. All right. It is a z-test, so I'm going to use the z equation, which is p hat minus the null. This is on your chart. It's not something you have to memorize. Okay? Over that standard error business. Okay. So, do we know what p hat is? 0.47. Yeah. So let's plug in our values. 0.47 minus, what's the p null value? 0.20, that's what we used in the hypothesis. All over this, we're using the null value in here. So I'm going to do it in steps. I'm going to find out that standard error real quick. So when you put in your calculator, I would do this piece first. All right, it's going to give you this long, nasty decimal. Then do the subtraction, then divide it by that long, nasty decimal, and it'll give you the z-score. Okay? Can we handle that? Cool. Good. All right. So there's my z-score. This is the test statistic. Your test statistic is either z or t, but since we're doing proportions, it's z. So my test statistic is 7.08. So if I draw a picture of the curve, remember, there's 0 in the middle, and 7 is positive, so it's going to be way over on the right. And then which way would I shade this guy? I shouldn't hear you. What'd you say? To the right. How come? How do you know? It's greater than, right? It's pointing to the right. All right. So then how am I going to find the p-value? How do we find p-values? You know this. How do we find this little area under the curve? Nobody wants to try. Calculator, but where in your calculator? Just look at it and say, give me that area under the curve. I don't think that's going to work. Huh? Second var is what? I don't know. What's 3? Which one? No, that one's where you put in area. That's where you give it the area.
No, that's not right. Is it just like the normal one? It's just. Oh, I don't know the name of it.
Norm, CDF.
Oh, yeah.
The normal one. Yeah, Pun intended, right? Norm CDF, peeps. That's what we're going to use when we have z-score. All right. It's been a minute, I know. Skittle brains, right? All right, what's the lower bound? 7.08, right? That's the lower boundary of our shaded part. What's the upper boundary going to be? Big junk number. Mu would be what? 0. Sigma would be 1. Remember, we're using the standardized guy, right? This is going to be a big number. Watch. So we get 7.25 e to the negative 13. What in the world is that? I got to move that decimal over 13 places, which is pretty small little number, isn't it? So what is that probability in reality? It's 0. So when you see that, you need to just communicate. That's approximately a 0% chance that we were just guessing. 0% chance we're just straight up guessing. All right. Now the conclusion is where we do what P. Diddy told us, right?
What?
Was it P. Diddy? No, it was Snoop Dogg, wasn't it? Skittle brains. Skittle brain. Skittle brain. Never mind. Rewind.
He's everywhere.
He's everywhere. No, he's not. He's not here. It
Because scary if P. Diddy was here.
so true. It was Snoop, right? Snoop Dogg?
Yeah.
Bless. God bless us. All right, what would he say? If the P is low, what are we going to do? Reject the null value. You said it. I didn't. Reject the null, right? So here it is. We would say since 0.000 is less than what? Lower than what? What'd you say? 0.05, alpha.
No.
The significance level. We compare that p-value to the significance level, which is 0.05. Since it's lower than, we reject the null. What does that mean in reality?
It's not true.
What's not true?
Evidence that it is not true.
We have convincing evidence of the alternative. What does the alternative say? That it's greater than 20%, or we're not guessing. the true proportion of Skittles guessed correctly is greater than 20%. All right. So, some things to remember here. If it's lower than, then we have convincing evidence. And of what we have evidence of, and all of this is just restating the alternative. It's always going to be the alternative. We either have evidence for the alternative or we don't. We don't ever mention the null value in here. Okay? It's always the alternative in your conclusion. It always starts with rejecting or failing to reject, and it ends with the alternative. Either we had evidence or we didn't. Okay? See how it's putting a bunch of stuff together in one question? It's a lot, right? So here we go. Summarize real quick. All right, it is a 4-step process. We're going to state the parameter, the statistic, the hypothesis, the null and the alternatives. Plan is to name the procedure, and the most important thing for you guys is checking those conditions. Remember, what are our conditions? Say it again?
No more random.
Normal and random. Yeah. Random and normal. With proportions, it's always going to be a large counts test, right? The next step is the doing, the actual calculating of the z-score, the p-value, sketching the curve, shading the curve, all the things. And then we conclude. We make our decision. And we put the conclusion in there in terms of alternative hypothesis. All right? Test details. Well, we're using z for proportion. So there's the formula. Again, it is on your formula chart. It's not something you have to memorize. You have to remember that z goes with the p-value, with proportions, right? Remember the Zaptax thing I showed you a long time ago? Z goes with proportions, t goes with means. So that's what you have to remember. One-sided test, remember, could be left or right. A two-sided test could be like this. Now, how do you handle it with the two-sided test? I'm going to show you here in this problem right here. Okay? Because you have two ends to work with, right? So it's just one little extra step. It's no biggie. All right, let's see if we can get through this one real quick. All right? Hang in there. Sometimes parents and grandparents like to recount how difficult life was when they were kids, such as having to walk 10 or more miles in the snow uphill both ways. You know the deal. Random sample of 180 teenagers were selected, and 40% had heard stories that their parents or grandparents about how difficult life was. Do these data provide convincing evidence at the alpha of 0.05 level that the proportion of all teenagers who've heard stories from their parents differs from 50%? So there's our key phrase, right? So P is going to be the proportion of teens who have heard stories. I'm going to keep it brief. Okay? Don't keep it brief just because we're running out of time. Okay? And you think that's too long? Bruh. What did their sample tell us? What did their sample say? What proportion came out of their sample? 40%. Everybody see that in there? That is the p-hat value. What was the sample size? Let's just pull that out while we're here. 180. Okay, we're going to need that in here a sec. All right, hypothesis. A lot of times it's easier to write the alternative first. So it says differs from 50%. So that would be p is not equal to 0.5, right? So if I know my alternative, then what would the null be? P is equal to 0.5. And what significance level did they give us? 0.05. All right. We're just kind of restating So we don't have to read that paragraph again. Name the procedure. It's a one proportion z-test. Let's check our conditions. Was it random? Yes, and we know that because it's stated, right? Normal. How do I check? Large counts test. So 180 times 0.5, right? Because that's the null value. Well, that's 90. That's easy. But that's greater than 5. And then 180 times 0.5, it's still 190. So we know it's approximately normal. Is that all right? All right, so let's do the work here. Let's find that z-score. Our sample value is 0.4 minus the null value. Let's see what that comes out to be. Zero, 3, 7. Okay. All right, so I get a test statistic of 2.68. That's what goes here. Now, the picture. This is a two-sided test, right? Excuse me. Notice our test statistic is positive, right? So that makes it on the right side. Now, it's all symmetrical. So if it's positive on the right, what is it on the left? Negative. So you can do this. You can just make it negative over here. And it's a two-sided test. And I want the sum of this area and this area. So what I have to do is find one of them, but since it's symmetrical, if I find one and just multiply by 2, I've got the sum, don't I? So either way you want to put it in your calculator is fine. So if I do norm CDF, if I do my lower boundary as negative 1,000, upper boundary as negative 2.68, just be careful, make sure it's negative. Mu is 0 and sigma is 1. All right, and I get 0.004, but here's the kicker. I got to multiply by 2 because of 2 tails, right? So it's going to be 0.008. All right, now we make our conclusion. And it starts like this. Since our p-value, 0.008, how does it compare to 0.05? It's less than, isn't it? So p is low, we what? Reject the null. If we reject the null, do we have evidence of the alternative or no? Yeah, we rejected the null. That means the alternative is truth, right? So we have convincing evidence that the proportion of teens who hear stories is what? What does the alternative say? is okay, so we would say different from 0.5, 50%, right? It's different than that. We don't know what, it's just different. That's all we've proven here, okay? All right. So far, so good? Do you see kind of the rhythm and the pattern of this? All right, will you remember it tomorrow? All right, one last burning question. Now, when you have a two-tailed test, it goes hand in hand with a confidence interval. Because it's like if you put these, it's like, remember when we did confidence intervals, we put a percent in the middle? And we ultimately found a lower boundary and an upper boundary, and we said the truth is somewhere in between. Remember that when we did confidence intervals, like last week? Yeah? It works like the same way with this, all right, when we do a two-tailed test. So we're saying that it's not 50%. It's definitely not 50%. We know that from this test, right? So it's saying a 95% interval for the proportion of all teens who heard stories came out to be this, 0.32 to 0.47. Using this right here, would you say that 0.5 is a possibility? No, why not? It's not in the interval, right? So we would reject the null based on this, wouldn't we? So you should end up with the same answer whether you did the hypothesis test or use the confidence interval. Did we end up with the same answer? Yes. Our evidence is different, but it's the same answer. All right. Explain how the confidence interval is consistent with but gives more information. So, okay, both conclude, I can spell, that we would reject the null. All right? But then it says, okay, what does the interval give us that the test doesn't? It gives us an actual range of plausible values, doesn't it? If I just had the test, I just know it's not 50%. I can't tell you what it is. But the interval tells us that it's less than 50%. Okay? So the confidence interval gives a range, I should say, of plausible values for the proportion that the test does not give us. Confidence interval gives us possible values for it. And it helps us to know it's really less than 50% of teenagers hear that. All right? So today's kind of a lot. Tomorrow we're going to do some more practice. I'm going to show you another way to draw a conclusion. Monday and Tuesday you're off, and guess what? You get another practice day on Wednesday. Yeah, you're welcome. You just cannot forget all this stuff. You're welcome.